that Chairman Smitherman showed you, the Midwest ISO, the California ISO, the New York ISO, PJM, which is the Mid-Atlantic ISO or Independent System Operator, and the New England ISO. All of those are all under our jurisdiction. They're all vibrant wholesale electric markets there. But we have yet to have a vibrant competitive transmission construction and development system in this country, and I think we need to look at the lead that Texas has put out there for us. They've thrown the gauntlet down, and I think the federal government needs to take it up and move forward with it. So that's why I really wanted to emphasize this with respect to Texas. And then I wanted to say another thing about Texas with respect to the resources, because I had the pleasure of having dinner with Chairman Smitherman a couple weeks back. And we were talking about Texas, and I said, well, Barry, how much wind do you have in Texas? And he said, well, we know that through this CREZ process, we can develop these transmission lines, and by developing them, we can, in fact, deliver to load something like 18 gigawatts of wind. And I said, well, but how much wind do you have? And he says, well, we don't know. And what he's telling me is that you literally have so much wind in Texas that it's almost limitless in the sense that it's a matter of how much transmission you can put in, and how many systems you can ultimately put in. So it shows you really how much resource there is not only in Texas but really in this country. We have virtually unlimited renewable resources if we can develop them, if we can get the transmission in, if we can deliver them to loads and get this done. So let's look at the country as a whole, something that a lot of people don't realize. Texas is somewhat of an island. ERCOT is separate from, electrically, physically separate from the rest of the country. There are a few weak interconnections between Texas and the two other interconnects, the eastern and western interconnect, but it's not interconnected in a strong manner. Neither is the eastern interconnect connected to the western interconnect in a strong manner. So each of these stands alone. But when you look at these three, you have to look at how we do the planning in the three. And right now, the Department of Energy finally, after all these years, for the first time, has put out some money to the three interconnects to allow for interconnect-wide planning. Now, ERCOT has been doing interconnect-wide planning for a while, certainly, and the CREZ process demonstrate that. But the rest of the country, the western interconnect and the eastern interconnect, have never done interconnect-wide planning. This is the first time. We're starting this now for the first time to do interconnect-wide planning. Why is that planning important? Well, if you look at the lines, and I think this was demonstrated by looking at what the CREZ process had to do in Texas, where there were really literally no lines in the upper part of Texas where the wind was. They needed to build the lines to move the wind. You've got the exact same situation in the rest of the country, where the major portions of wind are in the middle part of the country here. There are virtually no transmission lines. So ultimately, we have to do planning to figure out how we can ultimately make those lines planned in an efficient, effective way, and then move those lines to the loads, because the load centers are, of course, on the west coast and the east coast of this country. And I think it's within 150 miles of those coasts are about 75% of the electric users in this country. So you ultimately, again, have to figure out how those remote location-constrained resources can be effectively delivered to loads. Now, we deliver them to loads not only from the areas in the Midwest where you have resources, but also offshore. As I mentioned, off the Atlantic shore, we have the Atlantic shelf that goes out 150 miles and it's relatively shallow. You need to figure out how to, again, put in a system of transmission lines that will deliver it onshore. But you ultimately have to do it in a reliable fashion. Now, here, this, from a wind standpoint, shows you how some of the wind development areas are looking at. The one here that's 14, this large gray area here, is something that was proposed as a project called Green Power Express. It doesn't specify where exactly the lines are going to go, but ultimately you're going to move wind from this upper Midwest area in the Dakotas. In fact, there's an area here called Buffalo Ridge in the Minnesota Dakotas area. On that one ridge, it's a long ridge. It goes for 50, 100 miles, but there are apparently 55 gigawatts of developable wind energy on that one ridge alone. And so, delivering that energy, you've got to be able to figure out how to deliver it into the hubs of Chicago and the other population centers of the Midwest. And you have to do this with either direct DC lines, which is one option, which you've heard from the presenter from ABB. It can be done with high voltage AC lines, 765 kV AC lines, like some of the ones that Chairman Smitherman showed you that were being developed in the plans in SPP. But ultimately, this planning has to be done in a comprehensive way, and you're crossing state jurisdictions, you're crossing also ISO jurisdictions as well. And as you cross those, you have to figure out how to do cost allocations, which was something else that was talked about. And cost allocation comes under the jurisdiction of FERC. So we have to determine how to spread these costs among the beneficiaries who are going to use and ultimately then pay for these lines. And there are right now multiple ways to spread costs. You can spread costs in sort of a peanut butter way, where everybody kind of pays for the costs, or you can say, well, only the costs go to the specific beneficiaries of where the particular power is going to go, and have a very narrow definition of what the benefits are. So there's multiple different thoughts about how you can spread costs from an allocation standpoint, and we have to decide from an interconnect-wide planning perspective of how these costs are ultimately going to be spread. So all these things are going to come into play. The planning, cost allocation, and the other part is the siting. Right now, siting is done primarily by the states, and that can be problematic from the standpoint, again, if you're going from across multiple states and across multiple regions with a line, and you have one state that's sort of in the middle, doesn't want the line to come through that state, well, what happens? Well, there is some now what they call backstop siting authority by FERC. We have some ability in very limited instances where the Department of Energy designates a corridor as being congested, and they have to designate it ahead of time in some part of the country. And then if a developer tries to develop a line in that corridor that's designated as congested, and a state blocks it and does not within a year act, then they can come to FERC for backstop authority. We can try to backstop siting that line. But it's very narrow, and there's also been a court case that has limited our authority even more there. So there's now some bills in Congress to try to open that up a little bit, and I hope we're able to do that from a standpoint of, again, being able to develop renewable energy resources in an effective manner. So the other thing we have to do is also have to open up balancing areas and balancing authorities. These are the wind penetration levels in the western United States with a number of different utility companies across the bottom here. And the one that has the highest penetration is Bonneville at 30%. And right now, Bonneville Power Administration is trying to determine how they're going to stabilize the wind within their balancing authority. A balancing authority is an area where within that area, the grid operator controls that area and must keep that area within balance from a frequency standpoint. So they have to balance the loads with the resources, and they have to be precisely the same within like hundredths, because if they get out of frequency, then you get a blackout. Well, Bonneville's having all kinds of problems trying to figure out how to do that right now, and you can see some of the other areas in the West have a lot less wind in their area. Well, one way to solve this problem is to simply expand the balancing authority. If we did this in the West, for example, across these entire areas, instead of having a 30% peak load of wind in their area, the balancing authority area would only have 7%. So there are multiple strategies for people to use to integrate in these variable resources like wind and solar that do vary at times of the day and vary during seasons in ways that we can ensure that the grid is reliable. But FERC is responsible for the reliability of the grid. In fact, we're responsible for the reliability of the grid even in Texas. And as such, we have to ensure that under a set of rules that we've passed, that things are done to make sure the lights stay on. So integrating wind in and integrating solar in are very important to us. We want to figure out ways we can do that to maximize that integration, to maximize the development of those resources, those renewable resources, but do so in a way that does not impinge reliability at all. So those are challenges that we have. Now, there are other countries who are doing planning. In Europe, they're doing some extensive planning with respect to developing some of the offshore wind projects that you saw in some earlier slides, and developing solar, developing geothermal. They have in the Sahara region, there's a whole solar development proposal, and linking that into the European area, and then offshore wind in the North Sea.